folks, I welcome you back to Global Education Zone. And in this case, in this video, I'm going to be teaching you guys how to draw the views of a shape of a cylinder which has been rotated 20 degree. At least 20 degree to the horizontal. So in this case, first of all, we're going to be dividing the base into. We're going to be dividing the base using the base of this inclined surface. So it has now been inclined, right? So we need to divide the base. It has now been inclined. So I would draw a circle, divide the circle into 6 equal parts. So first of all, let me divide the line into 6 equal parts. So we have so let's divide it into 6 equal parts. So this is the midpoint. So actually this is 2 centimeters long. So I can try to divide into 4, but I want to divide into 6 equal parts. So I have 1 here to here. So I'll radiate lines. That's the first thing you need to do. Draw a semicircle and divide the base of the inclined surface into a number of equal parts. So in this case, we are using 6. So we are dividing into an even number of equal parts, and then we are going to project lines parallel to AB and to AD. So this is A, B. So this is the key surface. So we are going to be getting the elevation and end elevation from here. So we are going to project the points on AC and BD to the front and end elevation. So now the front elevation, as you know, will be above. So I'll just project. I have not drawn it yet, so I'll just project lines upwards. So this is I also form them from here. So project this upwards. Project the divisions upwards too. So and also here. Project the divisions upwards. Okay, so now we've done that. So the next step is I would want to draw I want to project them to the right for the end elevation. So present them to the right for the end elevation. There we go. This is the process, this is the procedure. Now I'm doing just that. So I also project the divisions to the right to get the end elevation. So I also have this one. Project that to the right for the end elevation. So now I've finished projecting the side. The next thing for me to do is to draw my front elevation. So I'll just create lines for that. The front elevation starts from here actually. So we need this for this. So it has a height of measure the height of. So I guess it's okay to use 1 centimeter. The height of 1 centimeter. So basically, you have this. This is still the same height as this. So make sure that's the height. So then I need to project the lines to the right for the front elevation. So there we go. So now the next thing is I will begin to transfer the distance from this center line to. So now there's a semicircle, as you can see. Now this semicircle, I'm going to be transferring the distance from each of these points to the semicircle. So this distance from this point, let's call this point 1, 2, and 3. So I'll transfer the distance from each of these points to the semicircle. I'll transfer them from the center. Let's call this center 0, from the center to the side. So at this number 1, we have let's call this let's 1 to 1. Let's call this 1 to 1 since they are similar to each other. At this 1, we have a distance from here to here. So we have this distance here. So let's have that here. So next we have though at the end of the day, this our front elevation is going to be longer than this though. All this distance here. Then we also have distance from 2 to the, so this from 1 to the 1 to it. It's actually smaller than that. So from 1 to it is smaller than that. From 1 to here. Then from 2 to the, that's the big one, that's the long one. Then from 1 again to the semicircle is smaller. So here we have, here. So we need for the A, we'll just transfer these distances to the right. Transfer the distance to the right. Those will correspond to our required points on the other side. So then next thing is to draw the intersection of these points with one another. So these 4 points, they have their intersections. So we have this, and then the bottoms, and we have the middle points. So this will form a curve. Let's draw the curve. This is the curve. So I don't need to use the French curve now because it's a rather okay. I need some section for the French curve. Okay, because of time, I can just trace lining with my hand. So this is how the curve will look. Obviously, the next thing I'll just trace this curve out. So trace the curve out there. And then here we go. We're good to go. So I will repeat the same procedure for the right side. So we have that here. We have the divisions, the intersection with this. So these intersections of the divisions with their corresponding sides, they form a part, and that part is the shape of the front elevation. So when we join all these points together, so I'm using my hand because this curve is too small for the French curve to fit in. So now the next step is basically we'll join these ends to form the complete front elevation of the cylinder. So these are the cylinder looks. So the circular base and the circular bases have been transformed into ellipses. So the last thing to do is to draw the end elevation. So I'll just pick a line from which the end elevation starts. So it starts from somewhere here. Pick a line here. It starts from here. So from there I'll draw a 45-degree line. This is a 45-degree line. Then I'll transfer each of this to this right. Transfer each of this to the right. So this will be the bottom sides being transferred. These are the bottom links. 3 and the number 4. Then we also have the top legs, the top divisions. So some of them coincide with the bottom divisions. So this coincides, then this doesn't coincide. So I have it the top division here. Then we have the third. Yeah. We have the fourth here. Then finally we have the very top. Now the next thing to do is just draw the curve of the intersection of these points. So for the top we have this. This is the span of the top. Then we intersect the midpoints, the bottom. So you have your curve. Yes, we do. You have the curve. Then this is for this side. So I can now trace the curve faintly. So it looks like an ellipse. So anytime you incline a circle to a plane, it looks like an ellipse. Then also have the bottom curve. You can trace the line of the curve, the point. These are the intersections. So you can see I'm tracing that with my hand. That's basically how it's done. I have this at midpoint. Then the remaining for this will go top. Then you can see they share some points. So the next thing is to trace a faint line through each of these intersections. We also have them here. So the next step is I will just stick in them, but this point is hidden, so we'll use hidden lines, hidden lines for this. These are hidden points. Next thing I'll just need to draw a thick straight line through each of these. So here we go. So I'm drawing all the points. So this is the shape of the end elevation of this. So when you're looking at the side of an inclined cylinder, you see ellipses, and these ellipses are intersecting. So this is the top, so it will also be shown, unlike the bottom, which will be hidden. So then you can also join these ends together. So there's a very thin line joining this. So this is how the end elevation of this looks. So this is the inclined cylinder at an angle of 20 degrees to horizontal. Then when you look at it from the side, it looks like this. So because this one has been projected to view, and this one's projected out of view. Then when you look at it from the left, you will see these two circles, intersection of the base and the top. And then you have a thin and perpendicular section. That is how it looks. So I hope you enjoyed this video, and I hope you've gained one or two things. Thanks for watching.